Okay, we're on section 2.5 now, possibly one of the more difficult ones in chapter 2. It's all about direct variation. So some linear situations model direct variation. So that's the y equals ax. And how we say that a lot of the times in your homework and on the test, it's going to say x varies directly with, or y varies directly with x. Oops, said that wrong, but that's how it says. Y varies directly with x. My slope, that's my a value. My a value here. Sometimes it's called the variation constant. My y-intercept is always 0. Always 0. So there's no number after that. It's direct variation. It's just y equals ax. So my graph of this thing, it always goes through that 0. Always goes through origin. Always goes through origin. That 0, 0 point. Okay. Rewrite the equation, if needed, right into y equals ax form. So we got the equation, it already is. Is it direct? Yes. There's no, it's just y equals ax, that form. Here we go, if we're going to solve for y, we've got to divide by x, so y equals 2 divided by x. So then, no, it's not direct, it's y equals ax, that doesn't work. This one is already equal to y. And no, it's not direct form because it's got that plus 2 at the end. This one, if I'm going to solve for y, I'm going to multiply by x, so I get y equals 2x. Yes, that is direct variation. It's kind of my example to that. Write and graph a direct variation equation that has 30, 5 as a solution. So my y equals ax. If I solve for a here, I'm dividing by x. So a equals y over x. Y over x. So in this chance, I got 5 for my y over 30. And if I simplify that, 1 over 6. So my equation is y equals 1 over 6 x. So I always am going to have 0, 0 as a point. Then we're going to go by 5s here. So 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. And on this side, let's go by 1s. 1, 2, 3, 4, 5, 6. So then it's always going to go through the origin, and 35 is my solution. So it's a line like that going through. Okay, flip the page. It says that variables x and y, vary directly when x equals 4 and y equals 8. Write an equation that relates x and y. So basically we're going to solve for a. So we got a equals y over x. So that would be 8 over 4, which is 2. So my equation, y equals 2x. That's it. Hailstones form when strong updrafts support ice particles, blah, 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 blah. And it says, normally we know that y varies with x. Means y equals ax. Well, right down here it says, write an equation that gives the diameter after t minutes if you assume the diameter varies directly with time. So it's talking about d varying directly with time. So we're going to place that in here. So diameter equals a times time. All that going on. Write an equation that gives the hailstone's diameter, let's put some light on here, after t minutes. So that's what I just did right here. So my x and my y that they gave me in the equation was after 12 minutes. So my x is kind of like my time. So after 12 minutes, my y, which is like my diameter, was 0.75 inches. So if I'm trying to write my equation, a equals y over x, So it would be 0.75 over 12, which is going to get you 0.0625. So my equation, diameter equals 0.0625 t. Just had to solve for my a value right there. Using your equation from part A, predict the diameter of a hailstone after 20 minutes. So plug in 20 into here. D equals 0.02625 times 20. And I'm going to predict my diameter is 1.25 inches. What did we learn how to do today? We learned about writing and graphing direct variation. Yes.